Determine whether the given function is a solution to the given differential equations. Now, if you remember those days many years ago when you were about to learn how to solve equations in algebra, before learning the methods to solve the equations, you did a few problems where you were given a number and you checked whether that is a solution of the equation or not. You plugged that number in the equation, and if what you got was true, then you knew that that was a solution, otherwise not. So this is the same idea here. For a differential equation, a general solution is a function of y. So in this case, they are asking us to check whether this function of y, the sine x plus x to the 9, whether this is a solution of this differential equation. Well, this differential equation has a second derivative of y and a y. So we will take the second derivative of y and then substitute that and the y in this equation and see if what we get is true. If so, then it will be a solution, otherwise not. So let's see. So right now we don't know whether it is or is not. So let's go to this step, which is about taking the second derivative. So let's find the second derivative of this y. So the first derivative is so I'm just writing out the first derivative here. So let's see, y, and let's do this, y prime, okay, it works, is equal to, so the derivative of sine x, you know, is cos x. And the derivative of x to the 9 will be 9x to the 8. So that's the first derivative, but in this box we have to fill the second derivative. So you take the second derivative of this. So that will be, the derivative of cosine is negative sine, and the derivative of 9x to the 8 would be 9 times 8 is 72, 72x to the 7. So negative sine x plus 72x to the 7. So let's change this. 72. And let's change this to negative sign. And let's get rid of that. Okay, so this is the second derivative, negative sine x plus 72x7. So when we substitute this for the second derivative and sine x plus x to the 9 for y, let's see what do we get in this equation. So we have this one, and then you add y to it. Y is plus sine x plus x to the 9. So I'm temporarily going to write it over here. Plus sine x plus x to the 9. So let's see. So now the sine x's will cancel out, and you get 72x to the 7 plus x to the 9, which is exactly what we have on the other side of the equation. So this was the left side. What I've written here is the left side of the equation, and that's exactly equal to the right side. Therefore, it is a solution. So now let's get rid of it from here. So when it is substituted for y, both sides of the differential equation are equivalent. So it is a solution. Okay. So it's the same idea here. the function theta. So now, right now, we don't know whether it is or not. So let's do the other steps first. Because, so now they are saying that check whether 3 theta is equal to 3e4 theta minus 2e 3e4t minus 2e3t is a solution of this or not. So this one has a first derivative, second derivative, and the theta in two places. So we'll substitute all these. We'll need to calculate the derivatives. Theta is already given. Because when 3e4t minus 2e3t substituted for theta, blank is substituted for the first derivative. So let's find the first derivative. So derivative of e to the 4t is e to the 4t times 4, and this 4 gets multiplied here. So it'll be 12 e to the 4t. And then this one similarly would be negative 6 e to the 3t. Is substituted for d theta by dt. And now let's see what the second derivative would be. That'd be 12 times 4 is 48. 48 e to the 40. 48 e to the 40. And then it would be, this one would be 6 times 3 is negative 18 e to the 3t. Now let's see what happens when we make the substitution. So we have these two, and then we have theta also going on. So this is, so let's do the steps over here. Then I'm going to erase it afterwards. So minus theta times d theta by dt. So theta is 3e4t minus 2e3t. So you're going to subtract it. So you'll have minus 3e4t. Okay, let's keep the negative outside. Minus 3e4t. And then you have minus 2e3t, 2e3t. So that's theta, and you are timing it with d theta by dt. And d theta by dt is this expression, 12e4t minus 6e3t, e4t minus 6e3t. Okay, and then we have plus 4 theta. Plus 4 times, and again we write the theta. That's 3e4t minus 2e3t. Okay. So now the question is, will all of this simplify and give us this negative 3e to the negative 3t or not? So let me just briefly tell you what will happen here. So here, when we multiply these two, you'll get 3 times 12 is 36, and e to the 4t times e to the 4t is e to the 8t. So the first term of this expansion will be 36e to the 8t. And then here, 3 times negative 6 is negative 18, and e to the 4t times e to the 3t will be e to the 7t. So you'll have negative 18e to the 70, and similarly here and here. So you'll get 4 terms out of this, and then you don't forget to distribute the negative on those 4 terms. And then you'll distribute the 4 over this, collect the like terms, and everything else should cancel out. If this is a solution, then you should be left with negative 3e to the 3t. And I will leave you to check that as I move on. So right now, I'm just going to erase, just for the record, that the second derivative was this one. Okay. So let's see. Okay, we should do this in the next segment.